This video will give an introduction to the trig ratios, or trigonometric ratios. Now, the trigonometric ratios are all based on a right triangle. Again, a right triangle is a triangle that has a 90-degree angle or right angle as one of its angles, and the side opposite to that 90-degree angle we call the hypotenuse. Again, something to remember, angle A is opposite side A, angle B is opposite side B, and our right angle, angle C, is opposite our hypotenuse C. Now, the trig ratios, by definition, are given as follows. There are three main trig ratios, and these are sine. And the thing that we need to be careful of here is that we always make sure to distinguish what angle we are acting on. These are ratios acting on a specific angle, and so we have to be sure to label what angle that we are looking for. So to start off, I'm going to look for the sine of A. Now, sine is always represented by the opposite side divided by the hypotenuse. And so this is why it's important to know that angle A is opposite side A, because in this case, the sine of A would be side A divided by the hypotenuse length, which is C. Now, the second trig ratio we are going to discuss is cosine of A, abbreviated as cos, but pronounced cosine. And this is the adjacent side divided by the hypotenuse. And if you haven't heard that word before, adjacent just means next to. So the adjacent side, the side next to our angle A, is this side B. Hypotenuse is still C. The third main trig ratio is the tangent of A, and this is the ratio of the opposite side divided by the adjacent side. So in this case, opposite to A is A, and adjacent to A, angle A, is B. Now, as I mentioned, it is very important that we distinguish which angle we are looking at. And I'm going to move this over so we have a little bit more room. We can also find all three of these trig ratios for angle B. We don't talk about these trig ratios for the 90-degree angle, that's the right angle, but we can talk about them for A and B. So in this case, if we look for the sine of angle B, well, opposite to B is side B, hypotenuse is C. For the cosine of angle B, we want to find the adjacent side, which in this case is A, divided by the hypotenuse is C. And the tangent of B is going to be the opposite B over the adjacent A. So you can see here how it's important that we make sure we label which angle we're looking at, because these are different ratios for each angle. One thing you might have noticed is that sine of A is the same as cosine of B, and this is on purpose because these two things are complementary angles, and we'll talk about that a little bit later on. But because these are complementary, that's actually where the co in cosine comes from. This is the complementary sign, or the sign of the complementary angle. The sign of the complement to B, which is A, and again, a complementary angle, or two complementary angles add up to be 90 degrees by definition. Likewise, the cosine of A is going to be the sine of B. Again, the sign of the complement to A, which would be the sine of B. Tangent, we'll get into the complements of those, or the cotangents, in a little bit on the next page. So if we want to find these three trig ratios for the given triangle, first thing we need to do is find the hypotenuse. We are given the two sides, we need to find the hypotenuse. you paid attention to the last video, I pointed out that there were certain Pythagorean triples that worked well within this, so you could guess that c is 5. Or you can use the Pythagorean theorem and say that c squared is equal to 3 squared plus 4 squared. You end up with 9 plus 16, which is 25. And then if you take the square root of both sides, you end up seeing that c is 5. So that works out with the Pythagorean triple we discussed before. And then we can make our ratios. We want to find the sine of angle A it was asking for. In this case, opposite to A is 3, and the hypotenuse we just found was 5. Cosine of A is going to be the adjacent side, which is 4, divided by the hypotenuse we just found to be 5. And the tangent of A is going to be the opposite, which is 3, divided by the adjacent side, which is 4. And so those are the 3 main trig ratios. We'll talk about 3 others here on the next page. Something also interesting to talk about is similar triangles, and we'll see an example of this on the next page. But essentially, one of the things we'll realize is that with similar triangles, you end up getting the same ratio no matter how big the triangle is, as long as that angle is the same. So just to kind of give you a definition of what a similar triangle is, similar triangles are 2 triangles whose corresponding sides are proportional. So, for instance, in this case, A1 to A2, our heights here, would be the same proportion as B to, if we called this entire length here, E, that B plus D. Those 2 ratios would reduce to be the same number. Likewise for the hypotenuse. If we called this C here, and we called this entire length here F, we would get the same ratio, C to F. All of those would come out to be the same number. And we'll see how this works here on the next example. So if we want to find the 3 major trig ratios for angle A using the smaller triangle ABC, which I have outlined in blue, or using the larger triangle ADE, which I have outlined in red. Now if we use the smaller triangle or the larger triangle, either way we need to make sure we find the hypotenuse first. So again, going back to Pythagorean triples, see if you can figure out what the hypotenuse is for the smaller triangle, the blue triangle ABC. So take a second, pause the video, and find the hypotenuse for both the smaller triangle and the larger triangle. So using the Pythagorean theorem or the Pythagorean triple, you should have found that the hypotenuse of the smaller triangle is 13, and the hypotenuse of the larger triangle, keep in mind here that this base is really 36, because it is 12 plus 24, so that whole base is 36. So this is going back to the similar triangle. If we take this 5, multiply it by 3, we get our 15. If you take the 12, multiply it by 3, you get 36. And if you take the 13 and multiply it by 3, you get 39. So those are all the same ratio. These are similar triangles. Now let's go through and find sine of A for the smaller triangle. If we do that, opposite is 5, hypotenuse is 13. If we look at cosine of A, and then we have the adjacent side, which is 12, divided by the hypotenuse, which is 13. And the tangent of A is going to be the opposite, 5, divided by the adjacent, 12. Now, if instead we find these ratios, the sine of A, based on the larger triangle, well, opposite is going to be all the way out here at 15. and that hypotenuse is going to be 39. We always want to make sure that we reduce fractions, and in this case these are both divisible by 3, so we end up reducing this to be 5/13, which is the same ratio we had before. Cosine of A is going to be, in this case, the adjacent side is 36, the hypotenuse is 39. Again, these are both divisible by 3, so we are left with 12/13, which was the same thing we had for our blue triangle, our small triangle. And the tangent of A is equal to the opposite, which was 15, over the adjacent, which is 36. And again, if you reduce this, you end up with 5/12. So the moral of this problem, or the moral of the story, is that no matter how big this triangle gets, because that angle A is the same, our ratios are always going to be the same as well. And so that's why these trig ratios are so important, because they're going to stay the same no matter how big or small the triangle is, because that angle is the same. This concludes the video on the introduction to trig ratios. The next video will discuss the reciprocal trig functions.